Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Devin.
And in studio with us we have Holly. And Holly, if somebody needed to contact us, what would they need to do?
For math homework help, call in Bakersfield 636-4357. Everywhere else, 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net. And on social media, Facebook, Instagram, Twitter, and YouTube.
All right, nicely done. So Holly, where do you attend school and what grade are you in?
I'm in 5th grade from Downtown Elementary.
And how do you like Downtown Elementary?
I really like it. I've been there since kindergarten.
Oh, wow. So you're pretty used to it.
Yeah.
And does it go to 6th grade? Does it end at 5th grade? I'm not sure where that school ends.
It's a K through 8.
K through 8. All right, so you've got a few more years that you'll be at Downtown probably, right?
No lockers. But yeah, I'm going to be there for a few more years.
All right, so if you could change something about that school, what would you change? Because you've been there for a while, you know the way it's run, and you're going to be there for a few more years.
Maybe make the sports teams a bit more, like make the programs a bit more accessible for the other kids, because once you really get into 3rd grade and 4th grade, that's when things really start to open up.
Okay.
When you're in like kindergarten, 1st grade, and 2nd grade, you don't really get to do that much.
Okay, so maybe
It's
have
really
some
just
options available for all of the students.
Yes, because in like 1st grade, 2nd grade, and kinder, it's really just like go to school, class, play with friends, recess.
That sounds like a pretty good day to me
sometimes
right there.
educare.
I'll do that
And
every
sometimes
day.
Eat a little bit,
Sure.
right? All right. So what kinds of things are you working on in math right now?
We're working on converting customary units of length and weight.
Okay, so
measurements.
customary units, what do you mean by customary units? Can you give me some examples?
It's like inches, feet, miles, yards.
Okay, so how can you compare those? So out of those that you named, inches, feet, miles, and yards, which is the smallest unit of measurement?
Inches.
All right, and which would be the largest?
Miles.
All right, and can you tell me anything about those, not just inches and miles, but any of those units of measurement for length? Like how
Well-
can you compare them, or if somebody said, well, I've got a yardstick, how else could you say, instead of I've got 1 yard, is there something else you could say?
Yeah, 1 yard is equal to 3 feet.
Perfect.
Or 36 inches.
Perfect, all right. So if a yardstick is 1 yard and it's 3 feet and it's 36 inches, could you then compare a foot with an inch?
Yes, because there
How
are
would you do-
12 inches in 1 foot.
Perfect, all right, so nicely done. So you've got the hang of the units and things like that.
Yeah.
So those are units that measure length. What else are you working on? I think you said,
We're also working on like length and weight, so like ounces, pounds, and I forgot. Oh yeah, tons.
okay, so what about time?
We're not working on time
Oh,
yet.
what was that, the last thing you said?
We're not working on time yet. Right now.
So that's coming up.
Yeah.
Okay, so what about weight?
Well, there are 16 ounces in a pound, and there are 2,000 pounds in 1 ton, which is also, there's 32,000 ounces in a ton.
So you've got quite a bit of knowledge up there
Yep.
already.
I've just memorized what I know.
All right, well, nicely done. You ready to do some math today?
Yeah.
All right, we'll get to that in just a few moments, but first, a reminder that we are in the middle of our 20th season this year. Actually, on the second half of the season, we've only got this month, and that is the only month left for live broadcast this season, and then we'll be back with season 21 once school starts again. I know I'm already talking about school starting next year. This
Wow.
year's
I
only
wanna be
still
on
in the
this
third
again.
quarter, but
Right.
anyway, we will go throughout the rest of this month as we celebrate our 20th season. Phone tutors are available most Tuesdays and Wednesdays throughout the regular school year. You see the phone numbers at the bottom of your screen periodically throughout the program. We'll get Holly to work in just a few moments, but first, it is time for today's Math in the News. All right, well, as I said, we are celebrating our 20th season this year on Do the Math. And earlier this year, we had a lot of opportunities for people that have been part of the program to come in and share their experiences with Do the Math, how they got started, how long they were here, when they started, all of their experiences, let's say. Some funnier than others, we could say, because a lot of things happen when we're on air. And it is live TV, so we don't stop and redo it again. We just keep on going. But I figured this month, the final month of our 20th season, we would take a look and have a little chat with everybody behind the scenes, because these people are critical to the program, and it wouldn't happen without the people behind the scenes. So you see Devin and myself, and all the other tutors are out here, but there are there's more of you behind the scenes than there are on the scene.
Correct.
So with us today is Willie. Willie, thank you first of all for coming out to be part of the program this
thank you.
afternoon,
You're
because I
more
know
than
everybody is always in the back doing something else. So what is your role with Do the Math?
Right now, I'm in charge of master control, basically to make sure that the signal from the program gets out into the world.
So master control, so you are responsible for making sure that Do the Math even is seen
Correct.
by everybody.
Correct.
So you are probably the most critical part to the whole thing.
And today we have the problem. We're not being seen by everybody.
Oh, okay. Well, here's a little bit of you in action. And explain what's going on there.
We're getting ready to start the recorder that we take and, what do I want to say? Put the program to bed
Okay.
so you can take and use it down the road.
And there you are on site.
On the site.
And a lot of times we can see that you are holding something. We'll get to that in a minute. Now this is a little something different than what you were doing
So
before,
now
right?
I'm confirming that we're actually out on YouTube.
Okay, so you've got to make sure. So you can go, all right, I'm pretty sure we're sending it out,
Correct.
but you need to see
Now
it
I can see it, correct.
and verify. So how did you get started with the Do the Math program?
John Lenko, who's a coordinator here, and I work at another site, and he found out that I was retiring shortly, and he says, when you're done, come see me, I got a job for you.
Okay, so you were retiring from what?
I was a senior electronics technician for the junior college district.
Okay, so this was just another avenue for you to take what you've already done
Correct.
and step right into it and not have to work as much as you did before.
I got to pick and choose when I wanted to work.
There
There
you go.
we
That is a
go.
sweet way to do it. You know what? Old man right here, I got a couple more years, then I can
That's
kind of
it.
pick and
That's
choose
Smarter, not
myself.
harder.
Pick and
That's
choose.
right.
I'll tell you, they work me like a dog, Willie. I'll tell you. I'm only kidding, but you know what? We all enjoy Do the Math. Now, this is what you were holding a lot of times when you're out on location.
On
So
location,
explain to us what this is.
This is what they call a shotgun microphone.
A shotgun
Hey,
microphone.
Shotgun.
I don't want any problems, man. Okay, I'm good.
It has a pattern that reaches way out and is very narrow, so I can take and kind of point and choose it at various locations
Okay.
and not pick up extraneous noises off to the sides. And basically, that's what the microphone looks like. And on the end of it, we have attached a wireless transmitter that will talk to a receiver on one of the cameras that we use in the field. And this normally is covered with what we call a windsock. It keeps the breeze noise from affecting the microphone sound.
So when you're outside particularly.
Correct.
Right, because a lot of times you can pick up that little
You hear
breeze
this-
going by and things like that.
Correct.
So would you use that indoors as well, or is
Oh,
it
yeah.
not as necessary?
No. This, it's there, so we just leave it alone.
Okay.
Because it'll also take, and if you're moving the microphone, you know, pointing
that
from
movement.
particular.
Okay,
people
and how
speaking.
far kind of you need to be from somebody? Because I know that a lot of times you're on location and you're standing, you're kind of hanging that over somebody.
Correct.
So how far do you need to be, or how close do you need to be in order to pick it up pretty?
Depending upon how we're standing or sitting, I can either come in underneath, no, it's not tight, come in underneath like that, as long as I'm below the shot
Okay.
that's being made. Or other times we come overhead and point it down and do the same thing.
So you would need to be in coordination with the camera crew also. To
Correct.
know what they're doing and the angles they're going at and the shot they're trying to get.
Correct.
And you're a master of this.
I have
Because
no
you've
idea.
been, now how long, so you have
10,000 hours.
been with Do the Math since the very beginning then?
No. It
So how
started
long
in
was it?
January of 2008.
Okay, so 2008, so you've been here for 14 years,
Correct.
15 years
Correct.
almost, so you're going to be here for a while longer because this is your side gig.
One of many, but
Yeah,
yes.
there you go, all right. So Willie, if somebody found what you did interesting and they wanted to kind of get into the field and find out a little bit more about it, what would they need to do?
I started in the electronics program at Bakersfield College, graduated in 2 years, and they asked me to go work for them, and I was there for 40 years basically. So saw various changes in the field of electronics basically. Got a radio license from the FCC, so allowed me to go out in the field and actually work on radio transmitters and television transmitters.
Okay.
And basically field work and desk work, repairing mostly equipment.
Now, radio transmitters and things, you're talking about field work, I'm sure you weren't one of the guys that had to go change those light bulbs at the top of the radio tower,
No,
right?
no,
Yeah.
you hire somebody to do that.
Yeah, I was going to
right.
say, I remember that. I remember a lot of times, you know, a new person would come to work for the radio station, you know, you kind of kid them like, oh, well, one of the first things you have to do is change the bulb at the top of the
Yeah, no.
radio tower and stuff.
No, I don't climb towers.
Nor do I, nor do I.
That side.
Anyway, Willie, we certainly do appreciate you taking out some time to come from behind the scenes, from Master Control. So once again, the show doesn't happen unless you are back there and making sure everything
That's right.
is pushed out
Correct.
to all of the different venues.
At this point in time, we're not going out.
All right, well, you know what? We're going to go on with the show and we're going to get it going out.
That's
So
it.
once again, Willie, thanks for coming in. That is today's
you.
Math in the News. 636-4357 is the phone number. In studio with us, we have Holly, a 5th grade student from Downtown Elementary. And we're about ready to get you back to work, young lady. You ready?
Yeah.
Head on over to the
go.
board. You and Devin are going to work on some of these problems right now. So the measurement and all of that stuff, customary units, you've got a pretty good handle on that, so we're going to move on from that. So taking a look at your math book, polygons is the next thing. So can you explain to Devin what a polygon is? And if you're kind of stuck, Devin will help you out, and that's where we'll start. All right?
I kind of forgot what they
Okay,
are.
not a problem. So I want you to think about if I were to illustrate some shapes here, okay? Such as this one.
A pentagon. Yeah.
Pentagon. Okay, now I actually want to talk about that term, pentagon, okay?
Penta, the Latin root meaning 5. I mean Greek root.
Okay? Okay? What about this?
God.
What do you think this could represent?
Shape.
Is this 5 shapes?
Oh, wait, sides. Sides.
Sides, or more specifically lines, right? If we think about a diagonal line, it talks about the direction that a line might take. So this term relates to lines, okay? So 5 lines for a pentagon. So then what would something like this be?
Oh, easy. Hexagon.
Okay, so if we know we know this is a hexagon,
Hexa means 6 lines.
okay, 6 lines. Great.
So maybe polygon means multiple lines.
Great, more than one. That term poly means more than one. So for example, if you were a polyglot, That is a word that means somebody who can speak more than one language. So a polygon is a shape that uses many lines.
Okay.
So there are other common types of polygons that you might be familiar with. Not all of them have this structure, but the more common ones do. So
I know one.
what's one off the top of your head? Now, what would that be called?
A square.
It could be a square, it could be a quadrilateral, a rectangle. If you were to draw a shape that has 8 sides, what would we call that?
Some kids might call it a stop sign because they use it as stop signs, but it is an octagon.
An octagon. And so octa meaning 8
Yep.
sides and lines. So yeah, a polygon is any type of figure or shape that has multiple lines.
Okay.
So that's the basis right there. So I'm glad that you put the square up there, because what is another shape that's very common that's not up there and only has 3 sides?
And what would we call that?
A triangle.
Okay.
There are 3 main different types.
That's what I wanted to get into next. Good. So you're going right there.
An acute triangle, which all sides are acute. A right triangle has one right angle. I'm not sure if this is actually right. Like, this angle is a right one, but... And then there's obtuse, where one side is an obtuse one.
So that's an angle that's greater than 90 degrees.
Yeah.
All right.
And
So
acute
you've
is less
got
than 90
acute,
degrees.
right, and obtuse for 3 different types of triangles based on their angle size.
Yeah.
Now let's go based on the side lengths.
Okay.
There are also 3 different types of triangles there. Are you familiar with those?
No.
Devin can help you out with that.
So if we think about a triangle very similar to the one, and this may not be to scale, but I'll do my best here. And all 3 sides have the same length. And we'll use these markers to represent similarities in lengths.
Okay.
This would be called an equilateral triangle.
Okay, so I recognize the equal, which means same. I forgot what lateral means.
Lateral, very much like gon, has to do with lines, or same lines or length. So all of the sides have the same lengths. All the sides are what we call congruent. They're similar to each other. Congruent. Congruent. Having the same properties. Now, there's 2 other types of triangles as it relates to their lines and how many of them have similar length. There might be a triangle like this, where 2 of the sides have an identical length, but one of them is a little different.
So maybe bilateral?
Close. This would be referred to
Irregular?
as an isosceles triangle.
Isosceles.
Isosceles.
Okay.
Now there's one more
Kinda
type.
looks like a person, by the way.
Yeah, it doesn't look very happy. I get what you're saying. And then there's another type of triangle where all of the lines have different lengths. So no 2 lines have the same length. This would be called scalene.
That
So-
is kind of like scaling with fractions.
Somewhat. This
Like
has more to
it
do
sounds like it.
with the length of each side being unique. So we have 3 types of triangles based on their angle measurements, but we also have 3 types of triangles based off of their side lengths.
So that's 3. Oh, God.
So you're fine.
Sorry.
So we have 3 types of angle triangles and 3 types of line
Triangle.
triangles. Yeah. So that means that, yeah, you could have, well, we can explore what type of combinations we could have, because some are possible and some you have to really think about.
Oh, I know one right off the bat. The
So
most common triangle. This one is a acute triangle. And it's also in a quadrilateral.
So an
triangle,
equilateral.
too.
And that's interesting because can an equilateral triangle be anything other than acute?
Nope,
Because all of the angles, what do we know about those angles?
because they're all acute at the same measurements.
So what measurement would that be? What is the measurement of each of those angles?
Any for this?
Oh,
I'd
good.
say,
So it'll go into
Yeah.
what are the total number of degrees in a triangle.
There we go. Okay.
right.
I'd
So-
say maybe 75 degrees.
We'll
for
talk about that a
each.
little bit later on.
That's just an estimate.
It's a good
Yeah.
start for an estimate.
Right, so that's going to come up next. So here's what I'd like you to do. Clear the board, and Devin, go ahead and put a square up there.
Let's go ahead and create
Can
a.
I
Or
do a
you can
square?
put a rectangle, it's up to you.
Let me do
Let
a
me do it.
rectangle.
Let me do it.
I've got one right here for you.
Whoa!
Excellent. So Devin, give us the length. Put whatever number you'd like to up there, and you can decide on the units as well.
Let's make this a rectangle with a length of, let's keep it straightforward. Let's keep this as 11 inches.
All right,
Okay.
now we need a width as well.
All right, let's make a width of 4 inches.
So Holly, if I wanted to know the area of that rectangle, explain to Devin what you would need to do.
So if you want to know the area, you first have to draw the triangle, which I got. Then the 11 inches and the 4 inches, you multiply them, and sometimes people like to draw lines to help them, but something pretty easy is just a simple multiplication problem. But sometimes these are really long, so my teacher taught us a lattice method, which, hold up, eraser.
Yeah.
Wait. But it is basically, you put it based on length, and you can use this for multiplication. So you divide it out to how many lines. So it's a single digit and a 2 digit. So you put the 4 on one side and the 11 on the other side. And then you could start anywhere you like. So it'd really just be 0, 4.
Now, do you
0.
know off the top of your head, if we're reflecting on our math multiplication facts, 11 times 4, is that a fact that you could reference pretty quickly?
Yeah, 44.
Okay, so basically, you can multiply the length times the width, and that will give you the area inside the rectangle. Now, is this just 44 inches for the area? Or do we have to refer to the inches in a different way?
Well, if it's 44 inches, it's square inches.
Right, because a square inch is an area that is 1 inch long and 1 inch wide. And we can fit 44 of those inside this rectangle. So,
You could do just
square
a
inches,
2.
absolutely.
You forgot the dot and I.
Well, if we're going to just be throwing dots everywhere, then we could do that all day. But
Good.
yeah.
And I like the way you introduced the lattice method right there. So that's a way that your teacher has shown you guys to multiply another way.
Yeah, because it was hard for some of my classmates to do this version of multiplication. Plus, it can get pretty long because, like, if you have a 2-digit to a 2-digit, you also have to do a lot of different stuff.
Yeah.
I didn't touch it.
All right.
But-
Well, I'm glad that you introduced some students to the lattice method right there. And with that rectangle that you have up there, we were able to figure out the area of the rectangle. What else can you figure out about that rectangle other than the area right now?
Okay.
Yeah, absolutely.
Well, if we're talking about stuff like that, we can, since we have these 2 lengths and it's a rectangle, so 2 sides are equal, it's also pretty safe to say that there's 4 inches right there and 11 inches right here. So we can also find the perimeter with this. So I'm
Okay.
gonna erase some of this work over here, just so we have some more room. I'm gonna
Okay.
erase this.
We've got plenty of room to work with here.
Oopsie.
So what would we do? Let's use this space down here, okay? How could we use these dimensions to find the perimeter of this rectangle?
It's
You can just go ahead and draw. That's fine.
okay.
Yeah. There you go.
So first, so we could do a multiplication, easy
I think she knocked her pen off.
Yeah,
There
here,
you go.
use the red one. Go for it.
We can do easy multiplication facts, like 11 times 2. That equals 22. So
Now,
that's pretty
why
easy.
2 instead of 4? Because last time when we were finding the area, we multiplied by 4, but here you're only multiplying by 2.
Well, since it's a rectangle, you go to the top right here and add them together. It's pretty easy when there are two of the same type.
So what you're doing is, it looks like you're adding these two, but instead of doing 11 plus 11, you're multiplying 11 times 2. Is that fair?
Yeah, and then we also got 2 times 4, which equals 8. And then we can add 11 and 8 together
Well,
to
11
get
and 8.
19.
I saw that I see you're mentioning you added 11 and 8. So where does 11 come from if 11 plus 11 was 22?
Oh! Oopsie.
So what I see that you're reflecting on is you want to add the
22
two
and 8.
lengths
22 and 8.
and then the two widths. So you're going to do 22 plus 8?
Yeah.
Okay.
That's right.
And what does that get to? You can keep writing with that.
Okay. 30.
So is that 38? 2 plus 8?
There.
There we go. So if you were to add all of the lengths and all of the widths of this rectangle, that would get you a perimeter of 30.
Oh wait, that's the area spot.
So that's interesting. Sometimes students do write the perimeter inside the rectangle, but from what I hear you saying, it's not very helpful sometimes because you can get it confused with area.
Yeah.
So
You could do like 30 inches somewhere on the outside.
and just to kind of illustrate that, or you could write equals the perimeter to show what you're
or you
talking
could
about.
do this.
Yeah. There we
There you
go.
go. Nicely done. You're well on your way. Just a reminder, we do have phone tutors available until 5:30 this afternoon. For your great work so far this afternoon, you've got yourself a meal courtesy of our friends at the Broken Yolk Cafe. So congratulations on that. All right. There you go. That's what I like to see. Excited about those
Right.
free meals. We'll be back with more right after this.
Okay.
Hello, we're here to talk about the language of mathematics. So there's a lot of special language in mathematics that we use all the time. And so one of the words I'd like to talk about today is absolute value. So a lot of times when we talk about absolute value, you'll be introduced to like a new symbols, and they look like this. So I wanted to start right away showing you what absolute value, how it's represented, and it's represented with two lines, okay? So what does this mean, right? So you might see like a 2 inside these two lines. You could see a negative. But what does this mean? So I'm going to explain how we would first say this and write this. So this is the absolute value of 2. And this we would read as the absolute value of negative 2, okay? But again, what does this mean? Well, what does absolute value mean? It means the distance from 0. So in order for me to highlight that and show you how that's represented, I'm going to go ahead and draw a number line, okay? So if I was to draw a number line, let me go ahead and quickly add some numbers to my number line. Put my negatives in there. Okay. So what does this mean? Well, if I'm looking at the absolute value of 2, I'm going to go to my number line and find 2. So here's 2. And when I look at 2, I really want to look at what's the distance between 0 and 2. So right away I can see there's a space here and there's a space here. So I am 2 spaces away from 0. So when I look at the absolute value of 2, I know the answer is 2. So now let's look at this one. What's the absolute value of negative 2? Well, again, similar to what I did here, I'm going to go find negative 2. So I'll find negative 2. And then again, looking at the distance from 0. So here's 0, negative 1, negative 2. It looks like I have 2 spaces again. So when I look at the absolute value of negative 2, it actually is also 2. So I want you to think about that for a little bit and how important this language is. Yes, this is a negative, this is a positive number, but they're both living inside the absolute value symbol here. So in order for me to find this solution or this answer, I've got to understand it's about distance. So if we're thinking about distance and measuring distance, it will never be negative. Okay, so when we're looking at absolute value, it's going to be positive. So let's go ahead and look at how else you might see absolute value. So sometimes when you're looking at absolute value, you'll also have adding and subtracting going on inside the absolute value, okay? Or you might have some other operations that are going on inside that absolute value. And so you want to do that first. For example, you might have 3 minus 2 inside. So we would go ahead and evaluate this. 3 minus 2 is 1. So then I can look at the absolute value of 1. How far away is 1 from 0? It's a pretty simple one probably, but I like to draw it out so that we can see it visually. And it looks like it's 1 space. So the absolute value of 1 equals 1. Okay, and again, remember, it would be a positive number. That looks like a V. Let's write it again, 1. So let's think about another one. Let's say we had the absolute value of 3 minus 5. So thinking back about our operations with integers, 3 minus 5 would actually give me negative 2. But I have to ask myself, what does absolute value mean? It means the distance from 0. So I can go back and look at a number line and think about how far away is negative 2 from 0. And so when I look at the absolute value of 3 minus 5, I know that the answer would be 2. So I hope that you've learned a little something today about absolute value. And remember, the absolute value has to do with the distance from 0. And that's why language is so important in mathematics, so that we don't confuse what we're doing or we don't try to apply something that doesn't work. But absolute value is pretty simple in that it is just a distance from 0.
And we will absolutely remember all of that about absolute value. Thank you to Hilda and today's episode of Language of Mathematics. In studio with us, we have Dre. Dre is from the Bakersfield Museum of Art. How are you this afternoon, Dre?
I'm good. Thank you for asking. How are you guys?
I'm wonderful. And what is your role with the Bakersfield Museum of Art?
So I actually am an art instructor for the Bakersfield Museum of Art. So I just go to different classes every day and teach a lesson or two.
Okay, and what will you be doing with Holly today?
So today we're going to be doing like a city landscape using division and watercolor.
All right, you ladies can go
All
to
right.
it.
Okay, so first step is we're going to have our paper horizontally and then we're
So
going to...
landscape?
Yes, landscape.
Okay.
So we're going to use our ruler and then you're going to measure vertically. So
Okay. So do I line it up or like how?
you can leave a little bit of space so you can mark.
So just like right here?
So how many inches is that? Well, so you're going to start at 0. Just like... So you
So I
line
just
it up.
measure how it is.
So how many inches is it total?
About 6.
6? All right.
Rounded, it's 6.
Yeah, so we're going to be dividing our landscape into 3 parts. So it's going to be the foreground, middle ground, and then the background. So 6 divided by 3 is how much?
2.
2. So you're going to mark every 2 inches, right?
Okay.
So 1, 2. And then you want to mark a little lightly. 2, 4, and then we don't have to mark 6. So you want to do it to both sides of your paper. So we did it on this side. Now we're going to do this side. So same thing, you're just going to line it up. And then it's 6 inches, so we're gonna mark every 2
just
inches.
get the paper
Yeah. So 2 inches here, and then 4-inch mark.
So 2-inch mark, 4-inch mark.
And then just to make it a little easier, we're going to make a straight line across to each one. And then we want to do it lightly so we don't see it under our watercolor. So just super light line.
Super light line. What if it's a bit bumpy?
That's okay. As long as you can tell what your foreground, middle ground, and background is.
Is that camera and staging in theater?
That's right, actually. I used to do theater.
I'll do it right now. Boom.
So can you locate the foreground, middle ground, and background?
Foreground, middle ground, background.
Yes, perfect. Okay, so now we can go in with our watercolors. I want to start with the background. That way we can paint over the background, right?
Okay.
So I kind of want to do like a purplish, like night sky. So I'm going to mix maybe like some purple and a little bit of blue.
So you do it over here, right?
Yeah. So just wet your brush a little.
Closer.
So you have some purple and then some blue.
I barely have blue.
So you can pick any color
Just
that you want
brush
to.
it in.
So I'm gonna add a little more water. And a little more purple. And then I'm just gonna go in. I'm gonna paint the entire background.
You did so much water. More water. More water. More water. Do you think that's enough water to start?
Yeah, of course. And then if you want to do like a darker night sky, you can definitely
I
add
am.
some more blue.
I am. I'm just waiting. Cause I like. Do.
So I'm also gonna go like kind of halfway into the middle ground. That way, like when I do my landscape, my city buildings, I'm sorry, I can, like the gaps will be filled in.
Okay.
And then some blue.
Do you like mine?
I do,
I'm
I
mixing
like that
with
color.
a bit of blue, purple, and green.
Nice. Green, I like that.
Yeah.
Oopsies.
So just paint the whole thing, so I'd paint 2/3 of it?
Yeah, so I would paint like the background and then half of the middle ground, just so that when we do our city, the gaps in between
Mine's
the buildings will
barely
be
showing.
filled in. It's barely showing? You probably need to add a little more color, less water. Yeah.
The blue. Underneath the green. Okay.
All right, so
Let
I
me try
got
this
my
now.
sky.
Oh, pretty.
That's okay. You can just like
I don't
even
care.
it out.
That's
with
like
the brush.
that's pretty.
I like that.
That's pretty.
Mhm.
Yours is. I think I might go over to Dakota blue.
Oh, nice.
Blue pretty. We don't get to use watercolors. We have watercolors in our desk.
Do you use them
Sometimes.
sometimes?
The most recent time we used them was when we made posters for our states.
Ooh, that's cool.
You
I
seen-
love using watercolor. I think it's like my favorite medium of art.
Don't really know what that means. I'm nothing I'm not as
So it's basically just like the type of art that I like to do. Like if you use a pencil, then that's like a pencil medium, right? So yeah.
I like sketching and then just drawing over it. Now for the hint of blue. Teensy bit. Go over it. Woo. Boo.
Ooh, I like that. I like the blue mixed in there.
Thank you. Just then you mix it. I think I made it out a bit more.
You think so?
Yeah.
All right, and then after that we can move into our
City?
Yeah.
Should we sketch out the buildings
Um,
first, maybe?
I like to freehand. I don't know if you maybe want to sketch it out, if you could over the water.
Maybe not when watercoloring, I think.
So maybe you can just watch how I do it, and then you can go from there if you're not sure how.
I'm actually pretty good. I think I might be able to paint the city.
Yeah.
Like, I just do black, wait for it to dry a bit, like very thin layer of black.
I like to just go in, honestly.
Yeah, I think I might do like a thin layer of black
Yeah.
for each because it's like night, so like the shadows. And then I think I'm going to just do like little dots, like the splatters
Like stars. Is that what you
in
mean?
the sky. And
Yeah,
then,
I was thinking of the same
ones,
thing.
And then the ones that'll land on the buildings, boom, windows.
Windows. That's cool.
Kind of wish I had a smaller brush for the windows though.
We actually have a little tiny brush right here. If you want to use that one.
Ooh.
So I'm gonna go ahead and start
Yes,
my
please.
city, okay?
Okay.
If you want to see. So I got a square brush because it was the easiest way to make a city. So
Yeah.
that's gonna be in my middle ground, right? So
That's only in the middle ground?
yes. So you can go above the middle ground line, but I like to just
Sink. I'm just drawing the outlines. They're all mostly different sizes. Oh,
yeah. I try to make mine kind of different sizes too.
Ooh, stop
So
building.
there's my city, and then I'm just gonna darken the bottom part a little. Does that look like a city to you?
Yeah,
Yeah.
that does. I'm still on the outline. Do you make different shapes for buildings?
Different shapes?
Like pyramids and stuff? Looks pretty.
It does. I kind of did like a more basic approach, but I like yours a lot. That's cool.
Then you just trace the line. Wish black, so I know where to start and where to begin. Anyone? I can do this at home if I want to, though.
Yeah,
right?
of course. So you would just need a ruler, a pencil, and then some paper and some watercolors.
Gotta wipe off a bit of water. Don't want a lot of water because there's already water. Okay, and
All right, so you can fill in your city. And then it's totally up to you. I kind of wanted to do like some water in the bottom.
oh, that'd be pretty. Like kind of like Salt Lake City in Utah. That'd be cool.
So I'm just gonna run the bottom with a little bit of water. That way I can do like a deeper blue and it'll blend nicely. How does that look?
That looks good.
Thank
I think
you.
I'm gonna do like a teal, like an aqua teal color for my water. Ooh, wrong color.
I think I'm gonna add like some purple shades on my water too.
Oh yeah, purple's pretty. That's with the little brush.
I'm sorry?
With the little brush, when you have enough water, it's like when I just like started painting with my big brush, it spreads.
It does.
So I like using small brushes for like details. Every artist needs at least a small brush and a big brush.
You're so right. That's exactly why I got us a small brush and a big brush. So I finished
That's
mine.
pretty.
Thank you. I like yours too. It's coming along.
Yeah. I like to put a
So
lot of detail into my art.
yeah,
Maybe add some windows,
that's true. I could add some windows.
because it kind of looks like they're just big holes right now.
Yeah.
I think if
If I can get my little brush out.
you can make it more city-like.
I should do like a yellow, right? Like as if lights are on.
Yeah. And then like you could do a pattern and leave some like out.
That was a really good idea. How's that looking?
Good.
Yeah.
And maybe like you could do one on each side sometimes, so it looks like windows are out. You know?
Mhm.
I mean, you gotta make your windows look like they're out sometimes, because some people gotta be sleeping. Like they might have school in the morning,
That's very true.
or they might be on to do the math.
So I'll probably skip a few, right?
Yeah.
So yeah.
Some people gotta be sleeping in your city.
Mhm. Even though they call it the city that never sleeps.
Yep. If all the lights are on.
All right. And then what color are
So
you
great
thinking of doing the
project that
bottom?
you've got there, Dre. So it all started with division, right?
Yes.
Dividing it into the 3 different parts
Yeah.
and then going into the watercolors. And if students wanted to know more about the Bakersfield Museum of Art, or adults as well, where would they need to go to?
So you can head to the Bakersfield Museum of Art at 1930 R Street downtown. Yeah, you can go ahead and walk in, ask about us, anything you might be interested in.
And as well as educators, because you said that you go to different schools and do art lessons, correct?
Yeah, yes.
All right, so if you want to have Dre or some of the other art instructors from the
Like Miss
Bakersfield
Ariana.
Museum of Art at your school, all you have to do is hit the website, maybe visit them on R Street. Wonderful displays and exhibits that they've got. Always something new and exciting down there. And we certainly do appreciate the Bakersfield Museum of Art helping us celebrate 20 years on Do the Math. We'll be back with more right after this.
Do I have to finish?
Aloha and good morning, everyone. We're looking at places that no one has looked before.
And this is part of NOAA's Office of Ocean Exploration and Research.
This is pretty amazing. These are Henricia, which feed on sponges. This is the slime star Hymenaster.
Oh, it is a pycnogonid. Look at that.
Oh, that's a beautiful bolosoma.
It's a polychelid. They're normally just sitting on the bottom and not swimming.
This is new for the Hawaiian region. This is a Phragastera. They are among the deepest known sea stars to live.
And this is absolutely the biggest Caulophacus I've ever seen in my life. I've never seen this before either. He's not sure which is bigger, the ROV or the sponge.
I think this is a Pythonaster. There are maybe 6 of these. I don't mean 6 species, I mean 6 specimens of these. There aren't any of this animal known from Hawaii.
You've given us a real puzzle here with that fish. I think we're going to have to work on that for quite a while to figure that one out.
You know, I hope you don't get offended by this, but I am delighted that I've given you a puzzle.
Yeah, well, this is why it's exploration. You know, we live for this stuff. We live for the new and the puzzling.
So Hawaii is interesting because it is the most remote island chain in the world. It has a somewhat low diversity of corals. These are also the deepest images ever captured inside the Papahanaumokuakea Marine National Monument. And so this is both an exciting and historic moment here.
Wow, look at that current.
Yep.
Oh, jeez.
These corals position themselves with the current and feed on small particles that are in the water column.
These boulders out here are premium habitat for a coral. Growth is not very fast, roughly about 2 centimeters a year.
These are enormous colonies right here. These are bigger than adult people, so some of these are over 2 meters in height. This is the first time the Okeanos Explorer is going to collect a biological specimen. This family of black corals has very elongate polyps. That bamboo coral is like nothing that has been imaged before from this region.
Certainly never seen this either way, if they're tentacles or mesenterial filaments. I've never seen anything like this on a corallium.
But this genus has not yet been published, and it's in the process of being named and described. This is all new, unexplored terrain.
And it's surprising us because it was not the community that we expected by any means. That's the thing about exploration, and when you're going to places that nobody's ever been, is you get surprised.
once, and I'll say it again, just fascinating, all of the stuff that we are learning this year about the ocean. All of those new corals, taller than human beings, some of those are right there, and just all of the different creatures that they are finding underneath the sea. In studio with us, we have Holly, a 5th grade student from Downtown Elementary. Just did some great work learning a little bit of division and watercoloring with Dre from the Museum of Art. I've got a totally different type of problem for you. Are you ready?
Okay.
All right, it has to deal with money. So Holly has $3.20. So you might want to put $3.20 up there.
Okay.
$3.20.
So $3.20.
20. I know how to write this as a fraction.
This
All
is
right,
great.
so
right
Holly has the same number of quarters and nickels. So quarters and nickels, you can just put Q and N up there if you want to abbreviate quarters and nickels. There are the same number of quarters and nickels.
Okay.
What is the greatest number of quarters that you could have?
So tell me how you would think out this problem as we're working it out, because what do we know is true?
We know that there are quarters that have the same amount as nickels.
Okay, and I see you're kind of labeling your quarters and your nickels here. So just to clarify, a quarter has
25 cents and a nickel has 5.
Okay, so you know that the number of quarters is equal to the number of nickels too, right?
Yeah.
So we can even write Q equals N. And then we also know that the value of each quarter is 25 cents, right?
Yeah.
So we also know that the value of each nickel is 5 cents. Now, when we add them all together, that means we're going to have $3.20, right? So what's the greatest number? So how would you figure out?
Well, first we could use basic facts.
Okay.
Like we could focus on the 20. We could separate $1.20 from it.
Okay.
Because using the same amount, you could have 4 nickels and 4 quarters.
So that's interesting. So what you're doing is you're starting off with 4 as kind of your base, right? So you know that 4 quarters.
The number has to be greater than 4.
That's interesting too. You're using kind of some reasoning here. So you know that starting at 4, just as your first arbitrary guess, you know that 4 quarters is $1 and 4 nickels is 20 cents, and the total for that
is $1
is
and 20
$1.20. So you know that this total has to be greater than 4. But you know that you have at least $1.20 with the 4. So where could you go from there?
Any other guess? I think a good guess. So they have to be both equal, right?
Correct.
So I'm gonna guess 7 next.
Okay, let's try 7.
Actually, no. 9.
You pivoted to 9 here, okay? So let's take a look.
9.
Let's try 9, okay?
And we have to add it to that 120.
So
it's
you're
basically
gonna figure out how much 9 is, and then add that to the 4. Okay, let's see. So if we have 9 quarters,
$1.50.
well,
dollars.
So $1.50 for how much?
1.
Well, tell me where you got with the $1.50 from.
Oh yeah, that's false.
Okay.
Hold up.
Because you're looking at the value of the 9 quarters first, right?
Yeah.
Okay.
So 9 quarters. There's 5, so that'd be 8. So it'd be basically $2 plus 25. So it'd be $2.25.
Okay. And what about 9 nickels?
I still have to add these 2.
Well, let's not add the $1.20 yet, because we remember there's the same amount of
Oh wait,
quarters
that's
as
not
there are
going to be
nickels.
correct though, because if you add just the 9 quarters. Oh wait.
Okay.
Right, you're not going to add them together.
Add
you're
this
just
to the
figuring out what 4 is and then 9.
Don't.
So.
False. I false.
Okay. Revising your thinking here. In fact, that's very helpful because it helps you realize that adding 4 and 9 would be too much for the 320, right?
And then and then 9 quarters, so that'd be 9 times 5, which is 45.
So we can say that 9 can be our next guess because we have 225 and then we have 45. So if we add 225 and 45,
Plus, it wouldn't be.
it'd be $2.70. So it's closer to 320, but not quite
I
there.
think we can get closer.
Okay, how much closer can we get, you think?
Let's try 1 closer.
Okay, so you want to
So-
add,
It'd be $2.25 for the
for the quarters, for
Quarters.
9 quarters, right?
it'd be $2.50.
So we're going to look at 10 now, basically, right?
Yeah.
So 250. Now,
And then
for nickels,
there'd be another 50
okay.
plus 50. That's $3. And
Right.
we can't get any closer.
Well, yeah, we couldn't get any closer with keeping that rule of having the exact same amount of quarters as we do nickels. So if we add another quarter, we're going to go over, right?
Yeah.
So if we have 10 quarters, we'll get to $3. But we'd still need to add some more nickels there as well
Yeah,
to
we
get
need
to
to add
320.
4 more nickels.
Yeah.
Right, and you solved the problem because it said, what is the greatest number of quarters you could have? 10 is the greatest number of quarters you could have. Therefore, you would have 10 nickels at the same time. You come up with $3, and you could have 2 dimes or a bunch of pennies and things
Yeah.
afterwards to get the 20 cents right there.
Yeah.
So a lot of students think that they have to land exactly on $3.20 with just quarters and nickels. You won't if you have them both being the same number right there. All right.
Okay.
So Holly, I've got a couple of questions for you. So I know that you would like to get some more sports involved for the younger students at Downtown Elementary.
Yeah.
But what is one thing that you learned here today on Do the Math?
Maybe that I learned more about triangles because I really only thought they're like those 3 types. Well, I knew there weren't 3 types because sometimes I peek inside my math book.
Yeah, there you go. There's nothing wrong
back,
with
the
peeking
gloss
inside
is
the
there for a
math
reason.
book, right? Because you want to see what's
But-
coming up.
Yeah, like I go far ahead, but I don't do it because I just want to see what's coming up. But I was like, oh, there's 3 other types of triangles.
Right, so you got them based on angles, and now you can also see that they're based on lengths.
Lengths.
All right?
Yeah, I'm ahead of my class.
There you go. All right? Did you have some fun today?
Yes.
That's the main thing right
I kind
there.
of want to come back next season.
Well, good.
Oh,
Well, we do have phone tutors available until 5:30, most Tuesdays and Wednesdays throughout the regular school year. And until we meet again, continue
Okay.
to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.